Hey students, welcome to Algebra 1A, where I want to go through some examples from your 6.02 lesson about relations and functions, because these questions are kind of unique to the way that they ask them in our class. And I thought it might be helpful to go through some video explanations of how they get their answers and also how they ask them. So this first one we got here is, what are the domain and range of this relation? And they have it written in sets right here. So if you recall, the domain is all of your possible x values, your inputs, and the range is all of your y values, or outputs. So taking a look at what's listed as the x values, we have -7, -2, 0, and 3, and they aren't going to repeat this 3 a second time. And so when I look through these options here, it's not going to be one of the first two, and I don't think it's a third one because that includes the number 7. It's probably going to be the last one here, but let's just double check with this 3, 5, 7 as the range. We do have 3, 5, 7, and it's not repeating the 5 and the 7 again, so I think that's going to be our correct answer right there. Cool. Next one, what are the domain and range of this relation? And so they did write this a little bit funny. There's quite a lot of parentheses here, but what's really going on in each of these sets of inner parentheses, like this one here, is they're writing basically a coordinate point of x comma y, kind of how we see it when we're graphing points on a graph or something. And what we can do to make this a little bit easier in your scratch work, if you want to make a table of those xy values, it's a little bit easier to see the domain range. So our first point is -5, 4. Put that in the table. The next point is 3, -2. And I'll draw the rest of the points here. So I got my table filled out, and we just want to see what our domain and range is going to be. The x values are -5, 3, and 4. The only option I'm seeing that has that is option C. And then the range -2, 3, and 4, that looks good too, because we don't have to write the 4 twice. So that's going to be our correct answer for that one. Okay, the last example I want to show you also looks a little bit strange. Pull this down a little bit here. I mean, they basically have all of your inputs basically in this bubble, or your x values and your y values in this other bubble, so you just can identify what those should be there. So I'm seeing 2, 5, 8 in two different options, A and C, and then let's just see which one also includes the range. Particularly, I'm noticing this -1.5 is not included in the top one, but it is in option C, so we'll check our answer with that one. That's correct. Okay, so in these examples, we are going to determine which relations are functions. And I want to remind you the definition of a function. A function is for every input, there is only one output, or another way of thinking about that is for each x value, there is exactly one y value. There is only one y value. And when we're looking at a table in particular, that basically means that x values cannot be repeated. So I'm actually going to look at the second example. This table's a little sideways, but it's easier to see. I have these inputs listed, and I see that the 1 is repeated. When I plug in 1 for x, I get -5, and I also get 7. And so whenever you are looking at a table and your x values are repeated, then that is not a function. So the x values cannot repeat if it is a function. Okay, so this one is not a function. I'll put a little x next to that one to help us remember that. And then let's look at the top example. I skipped over that one. I'll put this into a table here, an xy table, where each point is going to be given a little row there. So -5, 4, -4, 0, and I'll write the rest of them in. Okay, we got it looking like a table now. And for each x value, there's only one y value. And that's actually true. All of my x values have only one y value. It's okay if the y value repeats. It's only not okay if the x value does. And so this one actually is going to be a function. Let's look at this next one. For each x value, there's only one y value. That's true. My x values are not repeating. That one is a function. And then we've got these other ones here that are a little bit hard to determine based on the way that they're written. But if you notice the top one, -7, it goes to two different values. It goes to 2, and it also goes to 8. And so that one's not going to be a function. It's okay that the other ones are going wherever they're going. The biggest issue is with this -7 having two different outputs. And so that one's not going to be a function. And the last one, we have every x value has still only one y value. It's okay if two of them shoot over to the number 8 here. It's more that it's not splitting from one of those values. And so let's check our answers here. We got all those correct. Okay, let's take a look at an example of a graph. So we want to determine if this graph is a function, keeping in mind that for each x value, there's only one y value. So if I look at the x-axis here, I'm noticing when I look at -3, for example, and I see where that crosses the graph. It crosses it up here. Looks like it's just under 4. And it actually crosses it at a second point. It also crosses it down here at -3 point something. And so because at -3, it is crossing it at 2 points, this is not a function. And we can also sort of keep in mind the vertical line test and how this applies. If you draw a vertical line and it crosses the graph more than once, then it is not a function. We'll keep that in mind for our next example and determine that this is not a function. Check our answer. That's correct. For our last example, we've got some scattered points, but it still could be a function technically. And so let's take a look. Does there exist an x value that has more than one y value? Does it not pass that vertical line test? I'm noticing at -6, actually, it has more than one y value there. At -6, it crosses it up here at 8 and also down here at when y is -6. And so that means it's not passing that vertical line test, and it is not a function. So check that answer, and that's good to go. And so I hope you find this practice helpful in determining whether graphs and tables are functions.